All right, now that we know about significant zeros, let's learn about how to use significant digits in general. Now remember that there are formal rules and informal rules, but they all tell you the same thing about when zeros are significant. Okay? There are, and all the non-zero digits are always going to be significant in a number if it's been handled properly to start with. Okay? So what we're going to learn about now are the rules that apply to addition and subtraction. The rule. You can now. Okay? Magic. Okay. Yeah, the lights kind of play tricks on that camera. Alright? Now the rules for addition are the same as the rules for subtraction. In math theory, it could be argued that there's only one kind of math, and that's addition. You ever heard that before? Okay. So if you can add, you can do every kind of math there is. And that's what computers do. You know computers only have two digits? They have zeros and ones. So, binary code. Everything you get out of a computer, including this video you're looking at, come from ones and zeros. Okay? With addition and subtraction, computers only know how to add those ones and zeros. So how do they handle that? Well, subtraction is just adding negative numbers, isn't it? You could call that being another form of addition, right? And what would multiplication be? Yeah, adding the same number over and over again is multiplication, right? Okay. How about division? Subtracting the same number over and over again would be division, right? And then you can get the logarithms and exponents. Everything's addition. That would be the argument. Huh? What? A logarithm is an exponent. Most logarithms we deal with will be exponents on a base of 10. So like 10 to the second power is 100. A logarithm 2 is 100. That make sense? Okay, we'll get to that. The only time we use that is in acid-base theory, at least in high school chemistry. And that's when we calculate pH and undo calculations of pH. So we get the concentration of what I call protons in the solution. That is where the pH comes from. We just find the logarithm of that. All right. So addition and subtraction. Let's say we're going to add these numbers. Trying to think of something I haven't done yet with numbers, but let's just do milliliters of water. 1.25 milliliters of water and 12 milliliters of water. About that. Now I could give you a whole bunch of rules, okay, but I've got a simpler form of doing this that hopefully is going to make it clearer anyway. Fair enough? Okay? So here's what I want you to do. To find the significant digits when you have addition and subtraction, I want you to line up the numbers neatly in a vertical fashion, the way you learned to do it in what? Maybe second grade or third grade when you first started working with decimal places. So let's do that. Let's say 12.5. To line up 1.25 neatly, I need to keep the decimal place lined up, right? So 1.25, and then simply 12 over here, because there's a decimal place that we know is supposed to be there, right? And all of these are milliliters. Remember yesterday, or in the earlier video, you learned that you have to tell me what that number applies to, correct? So we want to say these are all milliliters, and these are all milliliters of water. So when you add things up, make sure you have the units of measurement and the species it applies to if there is a species. Okay, now we're going to add these together. And so we got a 5 here, and a 7 here, and a 5 here, and a 1 here. Correct? Okay, and this is milliliters of water. What? Oh, it should be a 4 here. No, that's fine. What am I missing? Oh, I left that out. God, see, I didn't line up my digits very neatly, did I? Very good. Good catch. Thank you, guys. Okay. All right. Now, trying to find a certain marker. Here we go. How are we doing back there, Patrick? You finished? All right. I got an errand I need you to run for me in a minute. Okay. Now, we don't know what digit was there, do we? I mean, suppose we'd measured this in a graduated cylinder that went to the tenths place, and we could estimate the last digit like we talked about yesterday. Okay? Then we know what digit belonged there. But we don't know what digit belongs there, do we? And it could be a 9 or it could be a 0. There's a lot of room there, isn't there? And we don't know what belongs here and here either. So this number and this number were measured in measuring devices, apparently, that were not as precise as what was used to measure this. So we don't know what those numbers would be. We do not know what these numbers should be. Does that make sense? So those numbers right there are insignificant. We don't know what they really are. So we're going to round those off. And this is the way you have to show insignificant digits. In addition, underline insignificant digits. Okay? It's required that you underline insignificant digits. Now the arrows, you can use those if you want to. I like to use them because it helps makes it clearer for me. Okay? You don't have to have arrows, but you can't put zeros there. Okay? Now I know you've been taught to do that your whole life in all your math classes. You're supposed to put zeros there to line up all the digits, right? Well, in a science class, you're lying about precision when you do that. Okay? If I put a 0 there, that's lying and saying, oh, that's a more precise number than it really is. If I put 2 zeros here, I'd be saying that's more precise than the measurement instrument I actually used. Does that make sense? So you can't put zeros there in a chemistry class. Got that? All right? And so this number really should have only 2 significant digits. And we're going to, now, when we round off, we don't use equal signs because what I'm going to round it off to is not going to equal this number. Okay, I'll be slightly less than that number. I don't want to use a squiggly equal sign because that really kind of means something else. What I want to use is simply an arrow. And it doesn't have to go around like that. It can go in any direction, really, just so long as you show an arrow. An arrow is the accepted way of showing that you're rounding off. Does that make sense? All right. So we're going to round off that 7 and that 5, which makes this a 26. Got that? Now just a word of sort of notification here. If you get into a higher end science class in college or something, there's a different set of rounding rules they'll use sometimes. Okay, they'll round up when it's an odd number and round down when it's an even number or something like that. I know that you've been taught 5 and above you round up and below 5 you round down, right? Or keep it where it is, which is what we're going to do in here. Which is, it's okay for here. Fine. Good enough? All right. But just so you know that sometimes there are other rounding rules, and there's a mathematical reason for doing that. But for now, we're not going to add more rounding stuff to what you already know. Okay? That's good enough. Is that fair? Yep.
I thought the point of significant figures was like to keep the same number of figures everywhere. Right? So what was the purpose of rounding off again?
Because this digit here that would have been here if I had measured this with a more precise device, we don't know what it is. Which makes the answer here, we don't know what it is. Not really. So that number is really useless to us in the real world.
Well, if you change the numbers before the decimal, we already know because that's common sense basically. And the numbers after the decimal, we had to round off.
Well, you have to round off anytime there's an empty slot to the right. And that's kind of the rule. Okay? If you want to write down a rule for it, line your numbers up vertically by the decimal, and then you round off digits in the answer that result from empty slots. Okay? Yep. Any other questions? Very good question, by the way. No? Going once? Going twice? Sold? All right. Let's let you practice now. All right? You practice now. Now, let me tell you about class practice real quick, because this is something I want you to use. I think that working with other students when you're doing class practice is a really good thing to do. So if you have someone right near you, I don't want you to get up more across the room necessarily, but someone that's kind of near you that you want to work with, you can do that. All right? The only time you can't do that is when I tell you on a test or a quiz. Got it? All right? Yes?
I like to kind of jump ahead, I'm sorry. But do we learn about, like, ionic and covalent bonds and how to name them and stuff like that?
Yeah.
Okay. Would that be calcium chloride or calcium dichloride?
No, this is calcium chloride.
Okay, I see.
It's an ionic compound, and you use those prefixes di, tri, and so forth only with covalent compounds.
Okay, stop.
All right, we're going to subtract this number and this number from 10.1. All right? So 10.1 grams. Actually, I should have left a space there. 10.1 grams of calcium chloride. And then I'm going to subtract 4.378. 4.378 grams of calcium chloride. And then I'm going to subtract 0.47 grams of calcium chloride. That makes sense? And there are going to be 2 empty slots here and 1 empty slot there.
So you would round where the empty slots are?
Exactly. Round where the empty slots are. Okay? So let's see, do it so you can see it, I guess, if you can watch me here. 10.1 minus 4.378 minus 0.47. Okay, and I get that number there. 5.252. Ain't lining up so good, but those 2 digits are insignificant. Correct? And then we need to round it off to 5.3 grams of calcium chloride. Got it? Well, the idea behind practice is so we can kind of clear some of that up, right? Okay. Did I not subtract it correctly? Well, if you think it's going to take that long, sure. Okay, now I'm recording the lecture today, so your responsibility is to catch up by watching the videos tonight, for anything you missed, okay? All right. Any questions about that? Don't move yet. Freeze. Real life. Well, I thought I explained this a couple times already. See, we don't know if this measurement here had been made with the same balance that we measured this with.
No, why do you need to know these? Are we doing an experiment that those?
We'll be doing those all year experiments in which you have to handle significant digits properly. The very next lab, you have to handle significant digits properly. Because if you don't handle them properly, you will be indicating a degree of precision in your answers that is not justified by the original measurements.
So if I give the scientist the wrong answer and it was way off with the stick and you start pouring chemicals, everything would explode. Not necessarily, but the outcome that you're looking for won't be right.
Could be. Could be.
I wondered,
There's a couple of famous stories in NASA They sent the Hubble telescope. When they first sent it up into space, somebody failed to do a conversion properly, and it didn't work. They had to launch a space shuttle and spend like 3 or 4 days in space putting in new equipment, spending millions and millions of dollars to fix it so it would work. Because somebody didn't do a conversion properly. Okay? Or failed to do a conversion. Okay? Yes?
Could you like walk through the subtraction again? I'm lost.
Walk through this?
Yeah.
Okay.
Like, add those.
It's real simple. Adding and subtracting. Put your numbers vertically, just like you learned to do way back in 3rd grade. Okay? Anytime there's an empty slot, round off the resulting digits.
I got confused the first time.
Well, normally, I would give you some homework to practice some more. The problem is I'm trying to avoid homework tonight because you're supposed to practice or study for the safety test tonight, right? Okay? Well, you'll get a chance to do this a lot in here, okay?
Okay. Well, what did you do when you got to the test, like the hundredth place? Okay, that's what it is. Like, what happened? Because that's what I messed up.
You keep doing the same thing.
Like, did you start off with like simple? Did you fill in zeros in the empty spaces and then subtract that way?
You don't put in the zeros. Because if you write down the zeros, you're lying about the precision. You're saying, if I put in 2 zeros here, you would be telling me, or if you put in 2 zeros there, you would be telling me that this number was measured on a device that went to that many digits. And it didn't. See what I'm saying? We want to be very careful because we don't want to mislead the people we're giving these numbers to. Yeah, that's what the arrows are for. You can put arrows in there.
Okay.
The arrows just mean, well, I'm keeping it lined up the way I would with zeros, but I'm not going to lie about the precision. Got it? You're overthinking it. It really is simple.
I got lost because I don't have a lot of practice like subtracting 3 numbers. Like I got
Okay.
to the middle place and I got lost.
You're adding
So,
the two negatives and then subtract the 10.
You can do it twice. You can use a calculator. Yeah. Okay.
What I got lost at is I put a 0 in the hundredth place and then I made it 10. And then you subtract 10 from 7 and you get 3. But you can't subtract 3 from 7 again because you get a negative when you get it. So I'm confused on how we got 5.
Yeah, you could do that. But now that in itself can cause, what you're suggesting can cause a problem. It's okay in this class. And we're going to actually end up doing some of this just because of the way I try to teach you to do it so you can practice. But really the very best thing to do is to do all the math and round off at the end. But we don't do that in here because it's too hard to keep up with for most high school students. Okay? Because what we end up doing, we end up what's called propagating errors the way that I teach you to do it. But in this class, I just want you to practice rounding off. Okay? Till you can do it in your sleep. Okay? Then you don't have to worry about it so much. All right? Got it? And you'll be using this all semester. Everybody clear? All right.